Welcome to this explainer. Now, since you're a space enthusiast, you're already intimately familiar with black holes. You know the drill. They're the universe's ultimate traps. Massive regions of space-time where gravity is literally so intense that it swallows stars, planets, and even light itself. Once something crosses that event horizon, well, it's gone for good. But in physics, every action often has a reaction, and equations frequently flow in more than one direction, which brings us to a truly mind-bending concept.
Okay, let's dive into this. What if the exact opposite of a black hole existed? Imagine a mysterious object out there in the cosmos that continuously throws matter and energy out into space, but is fundamentally impossible to enter. An object that might be connected to other universes, or maybe holds the key to the deepest mysteries of quantum mechanics. Today we're exploring one of the absolute strangest and most fascinating ideas in modern physics, the white hole. We're going to break down whether these cosmic fountains are real or if they're just a mathematical fantasy.
Section 1. The Cosmic One-Way Door.
At its core, a white hole is a theoretical cosmic object that behaves exactly like the opposite of a black hole. So, while a black hole relies on gravity that's so unbelievably strong that nothing can escape its grasp, a white hole operates entirely in reverse. It freely allows matter and light to leave its boundary, but it absolutely prevents anything from entering. Think of it as the universe's ultimate one-way door. No incredibly advanced spacecraft, no beam of light, not even a single subatomic particle could ever push its way inside a white hole.
And this brilliantly illustrates the difference. It totally flips the script. With a black hole, everything goes in. With a white hole, everything comes out. It completely turns our understanding of gravitational attraction on its head. But, where did such a wild idea even come from in the first place? It's not like scientists just looked up at the night sky and spotted one. No, they found it hidden on a chalkboard.
Section 2. Einstein's mathematical fountains.
Let's look at where this concept actually came from. The idea of white holes was birthed directly from Albert Einstein's general theory of relativity. You see, when physicists and mathematicians were crunching Einstein's incredibly complex equations to try and understand black holes, they stumbled onto a startling discovery. The math actually works perfectly well both forwards and backwards. So if you take the mathematical solution for a black hole and simply hit reverse on the timeline, it naturally creates a white hole. The math practically demands that the concept exists. Well, at least on paper.
To visualize this, think about it like this. If a black hole is a dark, cosmic vacuum cleaner sucking up everything in its path, a white hole is like a brilliant cosmic fountain. Imagine an incredibly bright object ejecting just enormous amounts of energy and matter into space. Unlike black holes, which are usually surrounded by a swirling accretion disk of doomed matter falling inward, white holes wouldn't have that. Nothing can orbit or fall into them. Instead, you'd likely see these incredibly powerful jets of particles and radiation continuously bursting outward. So from a distance, a white hole could actually appear as one of the absolute brightest objects in the entire universe.
But hey, before we start frantically pointing all our telescopes at the sky looking for these bright fountains, we need to ground ourselves a bit. As this quote perfectly highlights, just because the mathematics work out doesn't necessarily mean they actually exist. Our history of physics is full of perfectly valid mathematical solutions that never actually appear in nature. Math shows us what is possible within the rules of physics, not necessarily what's actually out there, hiding in the dark.
Section 3. Black holes versus white holes.
Now, what's really interesting about this slide is how stark the divide is between reality and theory when we put them side by side. Just look at the comparison here. Gravity, black holes pull matter inward, while white holes push it outward. The boundary, nothing escapes a black hole, but absolutely nothing enters a white hole. But it's those bottom three rows where things get real. We know for a fact that black holes form from collapsing massive stars. The origin of a white hole, though, entirely unknown. Black holes have been observed indirectly. We've even photographed them now, while white holes have literally never been observed. Black holes are supported by mountains of hard observational evidence, while white holes remain purely theoretical. So that begs the question, why do physicists still care so much about them?
Section 4. Mind-bending cosmic connections.
Because if white holes do exist, they rewrite the rules of the cosmos as we know them. Some theoretical models actually suggest a profound link between black holes and white holes, creating what we commonly call a wormhole. Check out this wild itinerary. Step 1, you enter a black hole. Step 2, you travel through a hidden tunnel in the fabric of space-time. And Step 3, you emerge from a white hole somewhere else entirely in the universe, right? It sounds exactly like a sci-fi movie. But mathematically, Einstein's equations actually allow for these structures under very, very special conditions. The big catch is that these wormhole tunnels would likely collapse almost instantly unless they were propped open by hypothetical, exotic matter packing negative energy. But going beyond wormholes, white holes might actually solve one of the biggest headaches in all of physics, the black hole information paradox. So the crucial point is this fascinating theory that proposes a black hole doesn't just sit there forever. Instead, over trillions upon trillions of years, through incredibly complex quantum gravity effects, a black hole might eventually transform into a white hole. If this is true, all that quantum information swallowed up by the black hole over its lifetime might eventually be released back into the universe by the white hole. It's just a beautiful, elegant solution to the paradox of lost information.
And let's take it even one step further into the mind-blowing territory. Could our entire universe have begun as a gigantic white hole? Some cosmologists have explored this highly speculative, but frankly amazing, hypothesis that the Big Bang wasn't just everything appearing from nothing. Instead, it could have been matter exploding outward from a massive white hole that was connected to an entirely different universe. Now, to be clear, we have absolutely no observational evidence for this right now, but it is an incredibly exciting hypothesis that really challenges our fundamental understanding of origins.
Section 5. The search for white holes.
Despite all this brilliant, elegant math, here is the stark reality. Zero. Zero confirmed discoveries. Modern telescopes, peering incredibly deep into the cosmos, across various wavelengths of light, have found thousands and thousands of black hole candidates. Yet, they have found absolutely zero objects that display the unmistakable, brilliant, outward-bursting behavior that we would expect from a white hole. So, why haven't we found them? Well, scientists have a few pragmatic theories for this absence. First, they might exist only for incredibly short moments during exotic quantum events, basically flashing in and out of existence way too fast for us to catch them. Second, they might just be exceptionally rare in our current epoch of the universe. Third, their physics might make them highly unstable, causing them to disappear almost instantly right after they form. And finally, the simplest answer, they may just be mathematical artifacts that don't exist in physical reality at all. But even without discovering one yet, the concept leaves us with some absolutely incredible cosmic facts to consider. I mean, think about it. White holes were predicted entirely by math, long before anyone even thought to look for them. Their very existence would completely violate our everyday, forward-marching understanding of time. And some bold scientists even think that tiny, microscopic white holes might be responsible for some of those mysterious, unexplained cosmic explosions we occasionally detect out there. Because of all this, they proudly remain one of theoretical physics' biggest, most captivating unsolved mysteries. White holes challenge everything we thought we knew about gravity, space, and time. They act as this humbling reminder that the universe undoubtedly holds incredible secrets that are still waiting to be uncovered. Perhaps one day, a next-generation telescope or maybe an entirely new breakthrough in quantum physics will finally peel back the curtain. But I want to leave you with this question to ponder as we wrap up this explainer. Do you think white holes really exist out there in the dark, waiting to be found? Or are they just the beautiful, abstract imagination of mathematics?